Hi everybody, welcome to today's webinar, Machining for Beginners. So just a quick overlook of the webinar and the agenda. So I think all of you received the description. We'll do a quick introduction about boundary systems. Then we'll jump, I think I prepared one slide, and then we'll jump into the presentation or into Creo and start machining some parts. After that, we'll have a question and answer session, but feel free to ask questions during the webinar. I'm only going to answer them once I'm done with the demonstration. Okay, so just quickly, something about myself. So I'm a boundary systems technical specialist. Been working for about 9 years now with the PTC product range, and I've done some mold design and machining before that and during my time with the PTC products as well. A little bit about boundary systems. So these are the logos of some of the customers we serve. We're a PTC partner. We also do bits and pieces of others like Solid Thinking, EdRage, and so on. And we're also part of the PDS Vision group of global companies. Some of our capabilities: product lifecycle management, data management. We also do CAD design and consulting, and simulation, and also product development. So that's how we serve these customers that you see on the slide. And then just some of the major accreditations. So we are a PTC Platinum partner. We're also a Winchell certified implementer, a PTC preferred provider, and then also certified training for Creo, Winchell, MathCAD, and Albertex products. And then just a quick slide about all the solutions we offer. I've mentioned some of them in the previous slide. I think the main focus is on the PTC range, but you can see there's a whole all different software vendors that we use as well. Okay, so just a one slider before we jump into the demonstration. So I think the most important thing when you start machining with Creo Parametric, you need to understand the flow of how things work. As soon as you understand that, everything is going to be a lot easier to understand. So this is just a big overview of all of that. I'm going to break it down during the demonstration, and you see everything I do will have a certain process to it. That's one that I found work for me. You don't have to use it like this. I think it's a good template or starting point. Everything you need to modify that or take bits and pieces of that and bring that into your company and into your scenarios. So everything in Creo is going to start with a part that has been designed. So with the new Creo Unite technology, that part can come from any other product or any other software vendor. You can import that into Creo Parametric, and you can start machining that. So that's the design phase of everything. So, and then from there you're going to go into the NC environment in Creo. So that's a specific type of assembly that you will create. From there you need to start thinking like a machinist. Then you need to specify coordinate systems, what type of machine you'll be using. Will it be only one type of machine? Will you go from a milling machine to a lathe to a wire cutter, for instance? So things like that you can do in one file, and from there obviously you go to the machine and you start machining your parts. Okay, so that's a big overview of the process. So I'm going to bring this slide back as soon as we start with the questions and answers at the end of the demonstration. But you can quickly take a snapshot of that if you want to. If you don't have time or whatever the reason might be, you can send me an email. If I can't answer it, if I'm busy with other projects, I'll make sure the correct person or the support team get all of that, and we'll answer your question as soon as possible. Okay, so let's jump into Creo and let's start machining some parts. So I'm going to start with the milling part. So I've prepared 2 parts, one milling and one turning one. I think there's a little bit more on the milling side of things that we need to discuss. So I'm going to start with that, and then halfway through, maybe a little bit more than that, I'll go into the turning part of things. But the process and the way that you will program those are exactly the same. So the first thing that we need to talk about is the type of assemblies that you will create in Creo. So I already created a milling one in this case, but let's just quickly recreate that. I'm going to show you how that works. So you're going to start a new manufacturing assembly, yeah, and we're going to do an NC assembly. So you'll see that there's a whole lot of different manufacturing type assemblies that you can create. Expert Machinist is a feature-based milling app or method that you can use. Then we also have the CMM sheet metal, where you can drive plasma cutters, laser machine, punching machines, things like that. Then we also do the mold and cast cavities, and we also have the additive manufacturing. So I've got the full license here. Depending on the license that you have, you will have the available options on the subtype. So for now, we're just going to work on a simple 3-axis milling machine, so nothing complicated. So we're going to say we want that, and we're going to give it a name, and let's call it milling 3-axis. Okay, so if your template is set up, then you can just use your default template. I'm going to untick that box for now, and I'm going to say OK, and it will allow me to choose files from my template folder. Okay, so what's nice about this is you can use these templates for various machines. So if you have a 3-axis machine with a specific post processor, or a 5-axis machine that you need to use in a certain way with default settings and things like that, you can have as many templates in here as you like. And then you can start off with that. So maybe there's already jigs and features in there. So things like that, certain layers, certain parameters, speeds and feeds for that particular machine, all of that can be in there. So for this exercise, we're going to keep it simple, and we're just going to use a millimeter start part. So I'm going to create that, and you can see I have my default data planes, and I have one coordinate system in there. Okay, so if you look at my other template I had, let's go to the milling one, I had my 3-axis in there as well. So I had my X, Y, and Z axis in there. So things like that you can have in your templates. So let's go back to the one I just created, and let's make sure we use default. So this is out of the box. I've done nothing to this file. So every setting that you see here is going to come from the out of the box setup for Creo. So I'm just going to maximize my screen. And then the next thing we'll need to do is we need to bring in our reference part. So I've mentioned the process that I will follow during these demonstrations. So this is the way that I use it as well. So I basically drive my dashboard from left to right. Right? So I don't need to create extra datum axes and sketches and things like that for this particular part. So I'm going to skip those. So the next thing that I need to do is bring in my reference part. Okay, so this is the part that you want to machine. So this needs to be your finished product. So there's a few ways that you can bring it in. I'm just going to use a standard reference model. So that's the model that's been designed. I'm going to bring that into my NC assembly. And let's quickly preview. So you have to preview when you open these parts. Let's make it a little bit bigger. So use the preview. That ensures that you select the right component that you want to do. We have the cover part. We also have a mold cavity. And I think this will be a nice one to use. Let's use our mold cavity. Okay, and I'm going to say open. So as soon as you bring it open, or as soon as you open it, you'll notice that the way that you assemble these parts is exactly the same way that you will use to assemble normal parts in the Creo environment. So if you are the designer and you make assemblies and you need to do the CNC machining side of things, then it's a lot easier getting into the CNC side of things because it's using the same interface and the same methods to assemble parts. And it's the same for sketches, it's the same for everything. Okay, so let's assemble the part. I'm going to use that top, and let's use the center. And I'm just going to, the distance one, I'm going to make that coincident. And then I'm going to use the center assembly, and I'm going to assemble it like that. I'm picking on this one. Okay, so there it is. Okay, so basically I told Creo now, so that's my reference part. So if I need to do gouge checking or anything like that, it's going to calculate that according to this component that I've added. So you can add more than one part if you want to, but that's more for the advanced type of things. Then you need to move from G54s to G55s, but you can do all of that in one assembly file. And so the next thing that we need to do is we need to add a workpiece around this. So this would be your stock billet. So once again, there's a few ways that you can bring this in. So I'm just going to use the automatic workpiece functionality, and it's basically just going to wrap a billet around my component. So you can see I will have some dimension values that I can change. So there's a value there. I can change the thickness, or I can use the option dialog box, and I can tell it, well, in X, I want it to be 700, and that's going to extend. So maybe for clamps or something like that, I need to add a little bit to my billet. So let's do that. Now let's say in the Z direction, I need to add 2 millimeters. Okay, so that will add to that. Oh no, I'm using the wrong one. I need that one to be 125, and I need this one to be 600. Okay, so you can add these. You can drag the drag handles, whatever's the easiest for you. So that's the automatic workpiece. I'm just quickly going to cancel that one. And one other one I want to show you is assemble workpiece. So this allows you to bring in any part and bring it in as a stock billet. So if you need special holes and things like that for clamping or certain dovetail grooves for 5-axis machining or for the clamps that's on your machine, you can design those billets and you can bring it in as a standard. Okay. So I can bring in anything. I can bring in that component now as a stock. So no limitations on there. For this exercise, I'm just going to use the automatic workpiece, and I'm going to machine that. Okay, so that's the workpiece. So the next thing, going down this dashboard, the next thing that we need to specify is the work center. So what will what machine will we use? What machine tool will we need to use on this case? So I'm going to use a milling machine. It's just standard. This is out of the box, so it's going to be a 3-axis machine. And I'm going to say, okay. Okay. The next thing that we need to specify is the operation. So the operation is basically the coordinate system that you're going to machine this part according to. So this is your G54, for instance. So I can go and I can create a coordinate system on the edge. If I'm going to pick up the edge on the machine, if I'm going to use the center of my billet, then I can create a coordinate system in the center of my billet. So this one's already in the center, so I'm going to use that. And so all my tool paths will now be calculated from this. So this is my G54. Okay, so as soon as I do that, then you notice that my cutting tools also became available now. So I can go and I can define some cutting tools. So I can do milling tools, I can do end mills, ball mills, tapping, reaming, boring, center drilling. So all of these I can go and create now. So remember this was now out of the box solution. So I don't have anything set up now. I have to go and do that. As you start working with Creo, you can save these machine setups, and you don't have to go and specify the tools each time. But that again, that all depends on how your shop floor is operating. If you change your tools a lot around and you have different things and different tools in and out of the machines, then maybe it doesn't make sense to go and add all of this, and maybe it's quicker to do them on the fly. It all depends on your scenario. If you have standard tools in pockets 1 to 5, you go and you do that for each tool that you specify. But you don't have to do that. Okay, so I'm going to cancel this, and I'm going to show you how you can specify the tools on the fly. So as I'm going to start machining this part, I'll create my tools that I'll need. And so I'm going to cancel that. And more windows, so that would be the next thing that we need to specify, but I'm going to show you how to do that on the fly as well. So the next thing that we'll need to do is we'll need to start milling this component. Okay, so let's start off with the roughing process. So I'm going to start roughing, and you can see now I can't do anything. I haven't created tools. So Creo is asking me to specify a tool. Okay, so I'm going to edit tools, and you'll see this is exactly the same window that I had when I picked the tools in the previous process. So I haven't measured anything on this component, so maybe we should do that first. Let's get some information out of this. Okay, so let's cancel that first. And we cancel the roughing as well, and let's get some information on this. So with the new model-based definition tools in Creo, you can go and you can create dimensions like you would do in a normal drawing. Okay, so I'm going to create on my front plane some dimensions. So I'm just going to move that maybe to the top. So I'm going to create some dimensions there. Let's see. Okay, so we're sitting with a radius 45 hole over there. That's a 30 radius. Let's see, are all these the same? Okay, so just yeah, it looks like all of them are the same. So I don't have a drawing, I don't have anything, and I can go and I can create some dimensions. Okay, so we're sitting with it's about 600 in length. Okay, so let's see how big this cavity is, more or less. That's about 285 millimeters. So this will give me some sort of idea what tools I can use. Let's get a radius in here. Okay, so that's a spline. So now I'm going to have I need a different tool for that. And now I've got all of these dimensions. Okay. So I can leave them there, or I can go and I can hide them if I want to, or I can erase them, whatever the case might be. Okay, at least I've got an idea now. So instead of going to the analysis tool and use diameter, measure that, so we say it's 60, you can use the model-based definition files, and you can keep them on the screen. You don't have to go and measure all the time. Okay. So you do what's best for you. If it's a simple part, you only need 1 or 2 dimensions. If it's a complex part, use the model-based definition things and leave those dimensions on the screen. Okay, so I've just hidden mine, and we're going to go back to milling. Okay, so let's go back to that roughing. I'm going to create my tools. So I saw this bucket is quite big, so I'm going to start off with about let's call it a 25 millimeter tool. You can give your tools a nice descriptive name. Remember, these lists can go through to a drawing or to the shop floor documentation at the end. So give it a nice descriptive name so the guys on the floor know exactly what's going on. I'm going to say this is an end mill, and it's going to be a 25 diameter. You can specify flute lengths, things like that. So 25, let's make that about 50. Tool length is 100. And I can say apply, and it's going to create that first tool. On the settings tab, so this tool is going to be in pocket number 1, and I'm going to use the same offset value. So that's the H value in your code. So depending on the post-processor setup, you can have different values there. Normally, it's the same as the tool number. In some cases, it can be different. It all depends on how the post is set up for your machine, things like that. Okay, so let's say apply, and we've got our first tool. Okay, so now the next thing that we need to specify is our mill window. Okay, so I haven't done that. So now we need to tell Creo where do we want to apply this roughing sequence. So do we want that 25 millimeter tool to go and dip into those holes? Maybe not ideal at this stage. Do we want to do, I think this one was 60 or even bigger, no, it was 45 radius, so it was a 90 diameter. Do we want it to dip in there as well? So the mill window is a way to tell Creo where to go in machine. So I can limit that, and I can just take the edges of the pocket, for instance. So the way that I'll do that is I'm going to go over here, and I'm going to tell it I want to create a mill window. It's on the right hand side, and that's going to create, or that's going to put me in the mill window environment. So how do I want to specify it? So this is basically a sketch, and you're looking at from your spindle head on a 3-axis machine, and you're going to limit it to that. So I'm going to use this the part top view, and now I can decide how do I want to do that. So it picked up some of the edges. I can specify the edges, so let me just get that. So I can sketch it if I want to, or I can pick a chain window. So I'm going to use that. I'm going to pick this. So now I've picked the outside. So maybe, there we go. So I'm going to pick that. Holding shift down, that allows me to pick just the edges. So I'm telling Creo now, okay, so I just want to do that pocket. You can specify a certain depth option. So let's say you have a part and it's 150 millimeters deep, but you need to machine it from both sides, or you only want to go a certain depth, then you can specify it there. So in this case, I don't think that's necessary. The pocket bottom here will drive that, and I can say, oh, okay, so on the options, you can tell Creo, do you just want to machine inside of the contour? Do you want it to go outside, or do you want a uniformly offset value for that? In this case, we just want to do the inside. Okay, so I'm going to say okay, and I'm going to resume my roughing, and I need to specify a clearance plane. So I'm going to tell it, well, you can retract 10 millimeters above my part. Okay, and let's quickly go and look at the parameters. So that's my cutting feed. So it was a default calculation or it used a relation to calculate that. I can specify the setup. So that's half my cutter. I've specified a 25 millimeter cutter. Step depth, 2.5 millimeters. We're sitting with 50 flute here. Let's increase that to about 15. You can specify tolerances. How do you want to machine that? So spindle speed, almost 2000 RPMs, coolant off. So let's just use that for now and see what we've got. So it's calculating the tool path. You can see this pocket is really big. The 25 millimeter cutter is going to work way too hard in here. So let's play that and see what happened. Let's maybe view that from the top. It's going to give us a better view of the type of tool path created. Okay, so it's a nice circular. That 10 maybe was a little bit too much. For the depth, you can see the steps down. Change that to wireframe. So you can see it did hit the bottom. A slight offset on there. Okay, so that's a starting point. Maybe not ideal. So let's play a little bit around with the parameters. And what I want to do quickly is just hide my stock for this exercise. So let's see what the spiral option will give us. Let's do a constant load. I like this one a lot better. It's a lot smoother. It's ramping down into my material. I like this one much better. Okay, so I guess my point with that is that you need to play around with the open scan area and the closed scan area. How do you want to machine those parts? It's going to be different for each part. You need to play around with it. You saw it's quite quick to go and show to get a view for that tool path. You can also show the tool path. So as you change it, it's going to regenerate and it's going to change that as well. So very nice, very quick feedback. Do you like it? Do you think it's perfect for the type of tool that you use? You need to make that decision. Okay, so let's leave it like that is at the moment. So once everything is done, it will calculate the time that it's going to spend on machining that particular sequence. Keep in mind, it is an estimate. I mean, there's a lot of rapid moves here. If your machine can only wrap it at 2 meters per minute, and another machine can wrap it at 20 meters per minute, then obviously that machine is going to cut faster. So what I normally tell the guys is you'll get a feel for the machining time. If there's a lot of rapid moves, maybe add 10%, 5%, and that will give you a more accurate value. But this is just cutting time, so actual shaving time, where you're creating shavings. Okay, so we've done that. So let's quickly go on to the next one. So all these re-roughing exercises work exactly the same way. So I can go from a 25, I can edit my tool, I can create a new tool, and maybe this is a 16 millimeter end mill. So we change the value to 16, flute length. Oh, sorry, I can't have brackets there. Let's call that end mill. Flute, let's call it 30. Apply, so that's going to create in my pocket number 2. And I'm going to calculate from my re-roughing. And then I just quickly want to show you what you can do. So you can go and you can use parameters from previous sets. So this is for everything that you in Creo that you can do. So I can double click that and you can see it took those values. But be careful now, my step over was 12.5. I'm sitting with a 16 millimeter cutter here. So maybe I want that 5. My step depth, maybe I want that 8. Okay, and I can go and I can calculate that particular sequence. So let's go and see. So you can see it only went and where that 16 end mill can go in, it finished that off. Okay. So I left my stock and all of that exactly the same. So it's only going to clean up where the 25 did not. But what I want to show in this case is that that your settings and your parameters and all of that is exactly the same. Okay, so let's do one more quickly, and then we need to move on to the turning component. So I want to create a trajectory milling. So this is really one of the tools, one of the sequences I use the most when I work with 3-axis machines. Okay, so I'm going to select my parameters. I'll just have a quick glance over that. Okay, so I think that's fine for default settings. And then I need to go and specify a curve cut. So I'm going to machine this pocket over here, that hole. I'm going to pick that, and it's going to machine that. Okay, so that's just dropping it. So, but what I want to do here is I'm going to specify a height, and I'm going to specify the bottom of my part as well. Okay, so you can see now it's using step downs. Okay, so that's not really going to give me a nice smooth cut. You're going to have those little marks on each. So I need to do 2 things. So I either need to add a lead in and a lead out, or I can just create a helical cut. Okay, so there's a helical cut. My pitch is way too big. So let's change that to, let's start with 10 and see what we'll get. Yeah, that's looking better. Maybe 15 will give us a nice, or less, 8 pitch. Okay, so it's going to start from the top, it's going to ramp in, and it's going to go down, and it's going to do a finish cut here at the bottom. Okay, so maybe for this scenario, you'll use this as a roughing cut before you stick in a remill or something like that. Okay, so the trajectory milling sequence, really a nice tool to go and use. You can use it on edges if you want to. Let's just use the outside edge. You want to machine edges to a specific size with the drag handles, you can just quickly extend that so it starts off the part, and maybe extend the end side. You can give it values, whatever the case might be, wherever you want to start. Okay, so things like that. So just trajectory milling, an easy tool to go and pick edges, get your finishing done with quick and easy picking and adding finish cuts, or you can add profile stock for a finish cut as well, or for a roughing cut, sorry. Okay, so we've got about 10 minutes left. Let's quickly jump into this to the lathe tool, but maybe I should just quickly show you the new simulation in Creo as well. So for the guys that's using the older version, we're not using Vericut anymore. We're using a tool from ModuleWorks now, and let's quickly go and simulate that. Okay, so you can set your precision and things like that. I'm just quickly going to run through that. Just quickly want to show you how the new tool looks like. Speed that up a little bit. So in here you can stop at collisions, you can stop at gouges, things like that. That's everything that you can set. Yeah, so that's how our part looks like after 2 roughing cycles and the injection milling that's not making any sense at that stage, and then we just ran the tool on the edge. Okay, so that's the new simulation tool. So if you're using the later versions, Creo, I think certain versions of Creo 4, the later versions of 5, and it's standard from Creo 6. Okay, and this is Creo 6, by the way. It's the latest version. Okay, let's quickly do some 1 or 2 sequences on the turning part. So turning part, again, starting with a default template, additional datum access, things like that already created. So the sequence or the process exactly the same. Start with the reference part. Here's the part that we're going to do. And then my XZ value is going to be that. So let's put that in my Z value. Well, that needs to be coincident. And then I'm going to put it flash with this surface over here. Okay, so there's my ZX. Okay, that should be fine. Workpiece again. So you need to specify a coordinate system. I'm going to use that. And then obviously we're going to use round bar over here. So you'll see it will grab, it will take the biggest diameter and it will grab that. You can add material if you want to, but obviously you can't drag it smaller. Okay, so that's great. So the workpiece done. Next thing will be what machine will we use? We're going to use a lathe, and we just have 1 turret and 1 spindle. So very basic lathe, just X and Z values or axes. Okay, then the operation. So same as your G5054, where will I calculate my toolpath from? I'm going to use that one in the front. And again, you can add your chuck or your clamps and things like that. You can add it in your tail stocks if you have those. You can add all of that in and then use it as features. So cutting tools, the same. So I'm just going to use a default cutting tool over here. I'm going to create that now, not on the fly. And I say okay. And then I go and I can go and turn. So exactly the same way that we need to tell Creo in the milling side of things where we want to machine, we need to do the same for turning. So we need to specify a turn profile. So there's a few ways that you can do that. So here's all the options. You can go and draw it if you need to. You can let Creo create them for you as well. So I'm going to pick my coordinate system. And you can see it calculated like a cross section through this component. So I can tell it, so where do I want to start? Where do I want to end it? Let's take everything for now, and then we can break it up as we create our toolpaths. So that one's great. So let's say, okay. And I can create another one. For instance, let's use the same. And I can say, well, I want that one to start over there, and I want it to end over here, for instance. Okay, so you can create as many as you like. That was not going to make sense there. Okay, then we're going to start with our area turning. So that's the same way as we're going to rough. So we need to rough out this component. We're going to pick our tool that I've created, and then I need to tell it what area do I need to turn. I'm going to give it this one over here. So now you can see there's a few things that's happening here. So that's not really ideal. The tool's obviously not going to fit in over there. I can already see in this corner over here where the mouse cursor is. I mean, that tool's trying to get in there. It can't go in here. So what I'm going to do is I'm going to just drag my end. I'm going to drag it up. I'm going to tell it, well, I want it to stop over there. Then I don't want it to break that corner. So I can just select my arrow. That's going to jump up. And the same with this side. So I can tell it, well, don't cut on the front of my bullet. I'm gonna shape that first with a facing turn or something like that. So I can pick on the arrow and it's going to create the tool path. Okay, so maybe in this case that one makes the most sense. It's going to start off my material and then it's going to run from the right hand side to the left. Okay, so let's say that's okay, then I can pick up a problem easily over here. That was a little bit too small. So let's see what's happening in this corner over here. Okay, so obviously that's not going to work for us. Okay, so there's certain parameters that we normally set when we start with the lathe things. So you will have like a template file, and those will be in there. So let's quickly go and set them manually. So it's on the cutting motions. So the gouge avoid type is set to only calculate for the tip. Okay, so that doesn't. So we need to do the side as well. Okay, and now you can see that section over there. That's clearing that tool now. So if we go and look at our tool, there's a 15-degree. So it's going on that 15-degree angle. Okay, so that would work. Maybe you want to groove that out first before you do this. All depends on the part and the tooling that you are running. We're giving you the tools to go and manipulate that or change the sequence as you would like. Another thing that I would like, what I normally use on this one, is I'm not going to do the rough only. I'll use rough and profile. So it will do the roughing and then it will just come and clean up the part as well. Adds like maybe a minute or so to the cutting, but then you get that smooth finish once you've roughed your part. Just a nice uniform finish on it. Okay, so that's roughing out the component, and then we can add a profile as well. So this would be our finish cut, and there's no offsets to it now. So you pick the same thing. This time I wanted to go just to there as well, and I wanted to drop just a little bit lower. So that's going to finish my outer profile, and then I'll come in with a drill or maybe a different tool, and or maybe my finishing tool is different. The tool 5, maybe that increased to 20, 35 degrees, whatever the case might be. So it's a new turning tool, and I'm using that now to finish my part. Okay, so let's quickly look at the simulation for this one as well. Also using the new module work simulation. Quickly play that. I think I made that that step down is a little bit too small, so I'm just going to make this a lot quicker. No, that finish one. See, I didn't change that. See, that tool can't get in there as well. So that's actually a gouge. So if I added my gouge, stop at collision or gouge in here, it could have stopped over there. Okay, so not ideal machining, but we need to set our parameters correct. So let's quickly do that. Change our parameters. And we need to go tips and slides. And let's view that. Okay, so there you can see it's moving above that. Okay. And then before we go into the question and answer session, if you go into the help files, so I know these parameters for the milling and the turning, there's a lot of options that you can choose. So you can go and save these files. You can recall them if you want to. I can't remember all of them, so I'm using the help files as well. So if you go File, Help, and you go into Creo Parametric Help, you'll see all the milling parameters. So use your find here. If you hit Control Find, you can type in anything. Let's call it scan, and it's going to look for the scan wording. Okay, so use that. Use the find to go and look for certain parameters. If you're not sure what it's doing, or you don't get a specific toolpath that you need, use the help files. Just a small or brief explanation will get you a long way. So this is the milling parameters, and you have them for the turning as well. Okay. So it's going to give you the scan type. It's going to tell you how the toolpath will generate. Okay, so I think that's what I wanted to show. It's very basic. It is for beginners. So I'm going to give you, I see there's already a few questions. So let me put the slide back with the contact details. So you can either email me a question, or I'll quickly mute myself and answer the few questions I have. Okay, so get those questions in, and I'll answer them. Okay, so I have one question about the mold milling, something I didn't mention. Let's quickly go back to that. So in the mold milling, we have this new high-speed roughing. So this is your waveform type of cutting. So let's quickly create. I'm going to use that particular, and let's quickly regenerate that. So this is the toolpaths more specific to mold making. Okay, so it's calculating. I'm not sure about my step depths and things like that now, so it might be, I might be overthinking it now. So let's give it a minute or so. So maybe I'll answer some of the other questions. So we had a question about the shrinkage that's been added. So yes, if you use the mold manufacturing license, there's shrinkage that you can add to your components, and then you will add the shrinkage before you subtract it from a billet or from a die plate or something like that. So yes, there's a specific shrinkage tool that you can use. And then I think I did mention about the time that it takes for a certain sequence or process. You can put it in a table format and show that in a drawing or any shop floor documentation. Okay, I think I should have just checked my parameters quickly before I've done this. Okay, so while this is running, I'm going to give you a few more minutes to get questions in. And then I'll answer them. Okay, so I'm just going to stop this one. Let's just view it from the top quickly so you can see the difference. You can see there's no hard stops or anything like that. So it's a nice continuous path all the time. So cut to life, load on the machine, things like that is really a lot less. And with this type of sequence, you can bump up the speed and feed as well. Okay, so depending on the material and the cutters and things like that, you can really optimize all of that. So this is part of the mold machining. So it's all these, zoom out. So you get the high speed rough, the rest rough, the finish, and the rest finish. So the idea behind that is just to pick your cavity, hit it with a roughing, hit it with a rest roughing, smaller tool, do a finishing and do a rest finishing. Okay, so you can break that up obviously depending on your cavity. Okay, so I'll give you a few more minutes to get in those questions. And so and there's one more question about the recording. Yes, the recording will be available. If you go to our YouTube site, they will upload it up there. It normally takes a day or two. So I think if you go and check it out by Monday, it should be up and running. If not, just drop me a mail and I'll ask the correct people to give us some feedback if it's not on the YouTube channel. Okay, so it seems like I've answered all the questions. Like I said before, if there's any other questions, please feel free to email me. If I can't answer it, I'll get the right people to answer it or even get PTC involved if we need to. Okay, so I'll end the webinar now. Thank you everybody for joining us and hopefully we will see you next time. Thank you. Bye.